Hi, let's take a look back a little bit about 2 weeks ago when we did polynomials, section 6-3. Terminology, some vocabulary that we need to know. Negative 3x, negative 4b. Any combination of coefficients, which are numbers, digits, and or variables, which are letters of the alphabet, separated by a plus or minus sign, are called terms. Remember how I've talked about these are pieces of a puzzle. The sign goes with the term. You could cut these out and move them wherever you want, but the sign comes with. Monomials. That means I have only one term. Example, 3x. Notice there's no sign. We all know that no sign means plus. You can add that in if you need it, but if it's the lead term, then you don't need to have the sign there when it's a plus. Binomial, two terms, 3x and then plus 4a. So I have two separate terms. They are separated by a plus or minus sign. Trinomial, three terms, 3x, positive 4a squared, and a negative 8, which of course we call a constant because it has no variable attached to it. Polynomial, it's a set of terms. It can be one term. It can go into infinity, the number of terms you have. Number of terms, you have to be able to count terms, the number of monomials linked together. Each one of these by themselves is a monomial. But when you link them together, you get a polynomial, multiple terms. Degrees. The degree of a polynomial is the value of the largest exponent. And this could be a sum of exponents within the term. I have an exponent of 4, a 2, and a 5. This is a three-term polynomial with a degree of 5 because that is the largest exponent. Written in standard form, you start with the largest exponent and then put each term in order. Remember, the sign goes with the term. A variable with no exponent at all has an invisible 1. We have a lot of invisible numbers in math. We have invisible ones all the time in front of a variable that has no coefficient. Rules and notes. Each monomial is a term. Monomials cannot have negative or fractional exponents. They are going to have whole numbers only. That means you need to clean it up before you start. No exponent means you have an invisible 1 as the exponent. Like terms. To be a like term, this is extremely important. You must have the same variables and the same exponents. The coefficients can be different. 2x squared y to the fourth and 5x squared y to the fourth are like terms. 2x squared y to the third and 2x squared y to the fourth are not. The y's do not have the same exponent, therefore they are not like terms. You cannot combine their coefficients. We need to group like terms, meaning combine their coefficients. You can order them into columns by exponent value to help you combine the coefficients. Sum of the exponents. Well, when you have more than one variable in a term, you must add together the exponents. Example, 2x squared y to the fourth. The sum of the exponents is 6. Therefore, that term has a degree of 6. 3x to the fifth, there is only one variable, so the degree is 5. There was one exponent with one variable degree of 5. We have something called a lead coefficient. By now you're noticing I'm introducing a lot of terminology that you're going to use throughout this entire polynomial section. The first coefficient, so that's the digit in front of the variable, the first coefficient in a standard form polynomial. You start with the largest exponent sum. I'm sure you're confused at this point. I want you to go back and read these. Here I have a term, 4x to the 4th power, a positive 8x squared, a negative 6 as the constant. I have 3 terms. It has a degree of 4 because that's the largest exponent, my 4. My lead coefficient, that's the coefficient of the term that has the largest sum of exponents. 4 was my largest exponent. My lead coefficient is a 4. Let's look at some more examples. 4x to the 5th a squared. I have more than one variable. Add my exponents together. I have a degree of 7. My lead coefficient, 4. 4x to the 3rd a. My degree is 4. Not 3. Remember, there is an invisible 1 with this a. A has an automatic exponent of 1. It's just invisible. You don't see it. You can put it back in if it helps you. Beware. 4x to the 3rd y to the 2nd and 5y to the 2nd x to the 3rd are yes-like terms. You can take any part of a multiplication problem and using the commutative property, you can rearrange the variables here. This equals 9x to the 3rd, y to the 2nd. You add your coefficients and you combine the rest of the variables. So you actually have 9, 4 plus 5, x to the 3rd, y to the 2nd. Standard form. You need to rewrite your polynomial in the order of term degrees. That means exponents. The largest degrees come first. Remember, the sign goes with the term. The coefficient of that term, the first one, is called the lead coefficient. So first, let's see what we have so we can clean it up. 2x squared y. I have a degree of 3, a 2 and an invisible 1. 4xy to the 6th. I have a degree of 7. Again, I have a degree of 6 and an invisible 1 with this x. Negative 2x to the 3rd y. That's a degree of 4. I have a 3 and an invisible 1. This is a constant. There are no variables. There are no degrees. I need to rewrite it in order of largest degree. The sign goes with the term. Positive 4x y to the 6th, negative 2x 3rd y, plus 2x squared y plus 4. Now it is in standard form. The lead coefficient is a 4, and it goes with the term with the largest degree. The constant always goes last, and the sign always goes with the term. This is just some basic knowledge, basic things that we went over. Hopefully you remember them. I'm going to go ahead and go through section, this is unit 7 that we're doing, but I'm going to go through chapter 6 and chapter 7 as we go through these 2 weeks of being at home and doing a little bit of e-learning and at home at our own pace. I hope you enjoy the video algebra, and I will see you soon. I was just going to introduce you to Lucy. one of my favorite peanut characters, who's joined me today while I did my videos. Bye now.